Okay, so now we're going to talk about cement and concrete. Just something off the cuff is that cement isn't technically concrete, although the terms are used so interchangeably. Everyone says, you know, when are they getting the cement? When are they pouring the cement? When they're pouring the concrete? And they use it as the same thing. Technically, cement is an ingredient of concrete. So it's sand, gravel, cement. Cement's the one we don't really like. That's what causes all the issues environmentally and is the nasty part of concrete. The rest of concrete is fairly natural, besides the additives or whatever, but cement is the big one. But they are technically different. Cement and concrete. One of the saddest things I ever see is these tilt slabs going up. I call them tilt slabs. It's when the walls are concrete as well. I had a big problem with well, I didn't have the problem, but there was a very large building company that had a big problem with a building and a lot of moisture and a lot of mold problems. They eventually went under, this building company, but I went back and forth about 4 times to this one unit that they were looking at suing them and so on. Because these tilt slabs, concrete is so moist and it holds all this moisture and they quickly cover it up and don't give it time to cure, particularly if it's come very quickly from where it was made and it's not allowed to stand there and cure for a while, and then it gets put up, gets clad, and we get problems. We stripped it, but they said it's all insulated. But a concrete slab wall, to insulate, they put polystyrene basically on, or glue it on there. But when we pulled the plasterboard wall down and looked at the polystyrene, it was like a broken jigsaw puzzle. So it wasn't what you'd expect to see, big slabs of polystyrene. They were pieces like this with big gaps like this in between everything. So the insulation was shocking. There was plenty of gaps between all the pieces of styrene. So yeah, tilt slab to me, these diagrams of tilt concrete slabs is a sad sight. Durable lifespan. Concrete has been around forever. Concrete has a lifespan over 100 years. It is tough. It is in my opinion, a very good building product. It's been around forever, and concrete is concrete. It's very good in terms of its lifespan over 100 years plus, for sure, if it's done well. A high structural strength and integrity. So yeah, there's no doubting it's very strong. Its integrity is very, very good. It can be molded, pre-cast into different things and tilted upwards, done whatever with. Can be used on floors, walls and roofs in domestic construction, homes and multi-story apartments, and it is done. It's extremely popular, concrete. It's a big issue where it is made. I've been involved in probably a handful now of cases where people surrounding where concrete is manufactured and particularly cut, where the dust just goes all over the cars and all of the neighbouring. They try desperately with water to keep it down. But crystalline silica in concrete is an issue. Concrete dust is a very big issue, has very low exposure standards. It's almost treated like an asbestos, not quite, but similar sort of thing that it can give rise to. It's a big issue if you work with it or you live or work very close to where it is made and cut. So, but it can be used on whatever you like in terms of floors and walls and so on. It has a very high thermal mass and can be used to store and release thermal energy. So that we know very well. It's its biggest advantage and why it's got such a good name, particularly here in Australia, because of its thermal mass. The concrete slab is like some form of gold here. But yeah, I'm not crazy about a concrete slab, but I think in some situations it's a great option. But I think to just lay a concrete slab wherever is not the right thing to do. But it certainly does store heat and release it later on. It always wants to equalize the temperature between it and the air above it. So if the air is much cooler, then it will release heat from the slab. And if the air is much warmer up here, then it will pull and make you feel cooler. It will pull that heat in. So, which sounds fantastic, and it is fantastic. It's a lovely regulator of temperature, if you will. But because it's such a big mass, if it's cold, like in Melbourne, and you're trying to heat it, it takes a lot to heat it. So in the winters, the concrete slab is cold. It's freezing, and it makes you heat the place more, and it's a real issue. Now, they bang on about how fantastic the concrete slab is. Try being a concrete slab where the sun is not falling on it and it's cold, it's a real issue. So you need to be careful. It's all about balance, always balance. So at 2,060 kilojoules per meter squared, dense concrete has the highest volumetric heat capacity of any commonly used housing material. Brick capacity, for example, is almost half that, a bit more, 1,360. So it's dense and it's got very good heat capacity. No one will sort of argue with that. Effective acoustic separation, that it does. It has good acoustics because it's so nice and thick and dense. So acoustic-wise, it's good. Resistant to fire and flood. So from that point of view, very good. The advantages. There's minimal waste in terms of a concrete slab because you pour the slab in there. There's very minimal spillage on the sides and whatever. You don't waste a lot of product. Not like other products where there's enormous amount of waste that goes into bins. Incorporates waste materials, fly ash. I really admire people in this sort of eco-concrete that they come out with now, and they put fly ash in there, very, in my opinion, very toxic waste product. I don't know if I had a concrete slab, if I'd want fly ash in mine. I don't know if I'm that dedicated to the environment, if I want that toxic stuff in my foundation and so on. But I do admire the fact that some people will live with fly ash in their concrete. Can be reused and recycled. And also the fly ash, there's debate around radioactivity and all of that as well. The fly ash is a bit of a question mark, but it certainly does get rid of a waste product and put it into the concrete. It can be reused and recycled. So like many materials which aren't, this can be reused and recycled, a lot in terms of roads as well. The disadvantages, it has a very high embodied energy. I don't think that's actually that bad because I think it's offset from the operational or maintenance energy. It requires very little maintenance and it lasts 100+ years. So if the embodied energy to get it there is a bit high, I think that can be offset, to be honest. Cold surface, that is difficult to warm. This is its big disadvantage. The dew point is easily reached, leading to increased condensation and moisture problems. Because it's like a big sponge concrete, it naturally holds a lot of water, which it must, and that's what it does. But it often holds too much if it's not done properly. And that can be a problem. Because it holds so much moisture, it will reach its dew point a lot quicker because there's moisture there already. And when you've always just got a slightly damp environment, that's where mold's an issue, particularly if you then got shading or other things going on as well. Poor hygroscopicity. It can take months for concrete to cure, resulting in condensation and mold, and may increase indoor humidity. So that we've discussed in detail. May incorporate a small amount of radioactive waste products. So between fly ash as well as the stone, of course it has some gravel, some stone in it. There's a risk. Wherever anything has come from the ground and it's a stone, there will be a risk. But how risky that is, you just have to see where it's sourced and whether that's a radioactive area or not. It's susceptible to electrical currents flowing on steel reinforcements in the slab. So this is because there's metal and steel reinforcement. There's a lot of metal. When you see concrete being poured and you see that massive steel reinforcement matrix going on before it's poured in, you'll see how much metal you're actually standing on. If that gets wet, it's a big issue. They call concrete cancer when it cracks and the metal starts to rust and degrade and then cracking occurs and so on. That's a real problem. They're working on bamboo, if you can believe it, reinforcement rods. They're trying to make that a reality. Already there is fiberglass that has been around for a bit, so you don't have to use steel. The fiberglass is easier to put down because it just clicks. It's a little click system, but for the actual product it's a lot more expensive. But if you want to get rid of the metal, the steel reinforcement, you can, and you can use fiberglass reinforcement. And it's susceptible to concrete cancer, which we've discussed. Building services, power, water and gas outlets and conduits and pipes must be accurately cast in and are difficult to add or alter later. Anything that goes into the slab, I'm extremely nervous about, particularly the hydronic heating, underfloor heating, all that. When you've got water pipes running in the slab, something goes wrong and there's a leak and it's only humans putting it in, the risk of something going wrong is always there. It's an enormous pain to try and find it. You've got to find where it leaked from because water will just be everywhere. You've got to find the leak, you've got to jackhammer, you've got to pull up the floorboards or the tiles or whatever's on top of it. It's a disaster. So if you do go slab, we don't advise going slab heating. We'd much more advise go radiant heating panels on the side and have the pipes where you can access them, whether they run in the walls or they run under the floor, but in the slab they can't run under the floor, but running in the walls rather than embedded into the concrete, especially services. We don't want stuff embedded in. It is embedded in, but I've seen many, many problems. 1 cubic meter of concrete requires 210 litres of water, of which 90 litres of unbound moisture will evaporate out of the concrete. That's an important fact. There is a lot of what we call bound water and unbound water. So of 210 litres, almost half is unbound. So almost half is going to evaporate out of it. It's not going to stay there. So if you don't allow enough time for that to happen, that's when the problems arise. So a 100 millimeter thick concrete slab will take at least 4 months to dry. As we say, how many people can afford to wait that long? But that is ideally what you do. A 150 mil thick slab will take up to 9 months to dry. So not many people who wait around for a year for the concrete to cure. So that's where we're at with concrete. I personally think it's a very good product if it's used in balance. So I like to specify concrete or some form of stone of similar thermal mass in areas where we know sun is going to fall on it. So when we know it's going to get a lot of sun, it can work for us. We can allow that sunlight in, it can fall on that concrete. It's always going, it's 90% of the time, depending on how often you get sunny periods, it's going to have warmth and it's going to emanate that warmth at night when it gets cold. And that is magic to have. So concrete is wonderful from that point of view. It's not toxic once it's laid. There are some additives, sometimes there's diesel and sometimes there's all sorts of other additives to emulsify it and so on. When it comes from the factory, it's not always just those basic ingredients of gravel and sand and water and cement and so on. There's some other stuff in there, but very little. It's mainly natural product and a pretty good product. I had another building biologist who hates concrete like I hate metal. Says concrete always cracks. That's its nature. Concrete cracks, and so just hates concrete. But I think that concrete, if it's laid properly, if it's allowed to cure, will cure a lot quicker if you don't lay as much, and you lay it at the right time of year, and you think about when you build. So if you do it properly, I think concrete can be your friend. I don't think it's the do-all and end-all like all the software programs make out, that concrete slabs just give you lots of points on your STAR accreditation for energy, but it's a good product in balance. So as an overall rating, I'd say it's sort of 6 out of 10. Not a fabulous product, but definitely not a poor product. I'd put it sort of bang in the middle on an average, fairly good product and material to use, particularly in terms of building biology. And that's the end of cement and concrete.